let's just head right on in. Okay, remember that for chapter 8, you always want to have your overview out in front of you. That overview is going to be your best friend this chapter. Specifically, you're going to want the overview for the parabola section. Okay, the parabolas. So, all right. So talk to me about what the two standard equations are. What is one of the standard equations? Question before I ask you for the other standard equation. What is in this equation that we also dealt with the circles? An H and a K. An H and a K. All right. In circles, I had H, K, and R. Okay. What does it look like I'm going to have for parabolas? H, K, and C. H, K, and C. Okay. Now, what is the other equation, the other standard equation? Okay. Yeah. And so we notice then that the two equations are only different in that my two globs are traded. The two globs are traded. Okay, that's the only thing that's different. In the overview, I went through all of the pieces of a parabola, and so make sure that you are aware of that. In the overview, what is C? What is C according to the overview? The distance between, say it again. Very good. It's the distance between the vertex. What do we call the vertex? Oh, it's not a center, it's a vertex, but still, what do we name it? HK. It's like the most important point, kind of like in the circle, the most important point is the center. In the parabola, the most important point is the vertex. Okay, and so we name it HK. So C is the distance from that guy, the vertex, to the focus. It's also the distance from that guy, the vertex, to the directrix. Let's play Sesame Street for a minute. Where is the focus? Can you just describe where it is? It is, okay, but when you're looking at the whole parabola, where is the focus in comparison to the parabola? Yeah, it's inside. Where is the directrix? It's outside. Where is the vertex? On. Okay, so that's why I said let's play Sesame Street. In, out, on. All right. Okay, so let's see here. Anything else I want to? Let's just jump right into the right into some examples. Okay, so we'll leave 12 alone. It's not highlighted. It's an easy one. Let's go down to number 13. By the way, these are continued numbering from the circles. Remember that all of these are in section 8.1. Okay, so I might take 2 days on 8.1 and 2 days on 8.2. So that's why the numbering doesn't start with number 1. The directions, give the focus, give the directrix, give the axis. All right, so we're looking at number 13. Now, when I look at number 13, what's wrong with number 13? Yeah, I don't have any parentheses. Like, it's hard for me to see. It is in standard form, but it's kind of hard to see what that standard form is. Okay, so look, can we try to rewrite this using some parentheses to try to figure out what my H and my K are? How on the left side would you rewrite this guy? Y minus 0, Y plus 0. I don't care which one you say because they're the same thing. Quantity squared. Okay. Is equal to, okay, for right now, can we just leave that negative 1/32 alone? Let's come back to that. Okay. So leave yourself some space after the equal sign and let's take care of the X piece. What's another way to write the X piece if I'm trying to match it to the standard equation? X minus 0, X plus 0, whatever. Now, what goes in that empty space that I haven't filled in? And you could say negative 1/32, but I'm actually thinking more along the lines of the standard equation. According to the standard equation, what goes in that empty spot? Yeah, 4C. And you go, okay, I get that 4C is the same thing as negative 1/32 because they're in the same spot. But how am I supposed to figure out what C is? Well, let's just set up a nice little fancy equation. Okay, the missing piece of my equation is 4C. This is over here on itchy paper to the side. The missing piece of the equation is 4C. And I know that that missing piece has been filled in with a negative 1/32. And now all of a sudden, it's just a nice little Math 101 pre-algebra equation. Solve, right? I want to get C by itself. So if I want to get C by itself, what's the best way to do that? Say it again. So you could say divide by 4, and you would be correct. But because I'm working with fractions, what's the better option? Dividing by 4 is correct, but what's the better option? Yeah, multiply on both sides by 1/4. Okay, so let's multiply on this side by 1/4. Let's multiply on this side by 1/4. Totally legal because I've done the same thing on both sides. On the left side, my 4 and my 1/4 cancel each other out, leaving me with C. Now, I'm not anti-calculator. You're totally allowed to use calculators in this class. Let's talk about that for just a minute. Are you responsible for getting your own calculators or are they provided for you? How does that work? Okay, so you are required to have either the TI-83 or the TI-84 for this class. Okay, so make sure, and we're not going to need it a ton in this first chapter, although there is some, you definitely don't need the graphing capabilities in this first chapter. But for some math, like what we're doing right here, it's helpful. But you are required to have an 83 or 84 TI. So if that is an issue, please just let me know. We'll figure out what to do. So go ahead. Remember, with multiplying fractions, you multiply tops, you multiply bottoms. Okay. So what does C equal? So what was that bottom number? 128. Okay. Okay, so now I can go back to my standard equation, and if I'm writing this just like the standard equation, I know that this is 4 times negative 1/128. There's my 4C. Now, remember I had 3 parts of the directions. What were the 3 parts of the directions that I was supposed to do? Which, for the record, I haven't done a single one yet. What am I supposed to do according to the directions? What's the first thing I'm supposed to find? The focus, right? The focus? Okay, so talk to me. Where is the focus? In any parabola, where is the focus? It's on the inside of the parabola, and what else would you say? How far away from the vertex? C away. Hey, I know what C is now. I know what C is, okay? Now, come back up here to these tips. I skipped over them because I didn't need them immediately, but now I need them, okay? I've got 4 tips for you. First, sketch what you have. Second, determine concavity. Is this concave up, concave down, concave left, concave right? Third, figure out which standard equation we should use or is being used. And then fourth, find H, K, and C, the 3 things that we got to have. By the way, these don't have to go in that order. I can mix and match depending on what I'm working with. Okay? So let's just see if we can visually figure out what this thing is. Where is my vertex? Yeah, how do you know it's 0, 0? Because my H and my K are 0 and 0. Okay, so the vertex is going to be at the origin. All right, so I'm in the middle of sketching what I know. One of the things that my tips say is to figure out what kind of concavity do I have. Is this a concave up, down, right, or left? And when you answer me, I'm going to ask for 2 reasons why you're answering what you're answering. Up, down, right, or left? Let's talk categories first, okay? Is it an up, down, or is it a right, left? It's a right, left? How do we know that? Because my y's are squared. Remember back in Math 110 last semester when you guys were working with parabolas, the entire chapter 3? All of them were something like y equals ax squared plus bx plus c. Remember that? Where my x's were what squared? When x is squared, it's a normal parabola, up, down. But when my y's are squared, it's a new type of parabola that you guys haven't worked with before. It's going to be either opening to the right or it's going to be opening to the left. Okay? So this one I know is a right-left parabola because my y's are squared. Okay, now let's settle down a little further. Is it right or is it left? Why is it left? C is negative. C is negative. Okay, so there's 2 reasons for it opening to the left. One is that it's a y squared. 2 is that it's a negative C. Okay, so I'm not going to draw a whole lot here. I'm just going to draw enough of the parabola. That's to the right. I don't know my right from my left. Sorry. Hang on. Let's try that again. Let's open to the left. Okay. So then in which direction am I going to find my focus? Up, down, right, or left? Left, because remember the focus is always on the inside. How far away is my focus? C away. Question. If I were asked to draw a focus, what kind of figure would I be drawing? Say it again. A point. And so if I ask you for a point, what kind of symbolization are you going to use when you give me the answer? It's going to look like a coordinate. You're going to have parentheses. You're going to have 2 numbers on the inside with a comma between. That's how we write points. That's how we write coordinates. Okay, so my focus. You already told me my focus was going to be found to the left. You told me how far away it is. So at what coordinate is my focus? Which one is it? Is it 0, 1 over 128, or is it 1 over 128, 0? 0 first or 0 second? Second. Okay, because I'm moving on my x-axis. Okay, now question, what is the first number? Negative, because I'm going to the left. Negative 1 over 128, comma 0. So there's my focus. Which direction do I find my directrix? To the right. How far? C. If I asked you to draw a directrix, what kind of figure would you draw? Oh, a line. And so when you write a line, when you tell me, here's the line, how do you write that? You don't write it as a coordinate. How do you write it? You use a line equation, don't you? Okay, let's take that a step further. What kind of a line is this directrix? It's vertical, right? Because you can't touch the parabola with your directrix. So it's got to be vertical. Every other horizontal line would touch the parabola. So if this is a vertical line, what equation do all vertical lines have? X equals a number. Okay, so now let's take that a step further. You're asked for the directrix. So what am I going to write down? One over 128, because it's going to the right. It's going in the positive direction. Okay, what was the third thing I was asked for? The axis of symmetry. Thanks. Okay. What does an axis of symmetry do to a parabola? It cuts it in half. Okay, if I asked you to draw an axis of symmetry, what kind of figure would you draw? A line. So when I ask you for the axis of symmetry, what is your answer always going to look like? It's going to be the equation of a line, right? All right, now you see my little picture of a parabola up there. What kind of line is this axis going to be? It's going to be horizontal. And all horizontal lines have an equation of y equals a number. Okay, so my axis of symmetry is going to be y equals, what is the line that cuts my parabola in half? Y equals 0. Good. And those were the only 3 things I was asked for, yes? Okay. All right, let's skip number 14, but I need the directions to be able to do the next question, I think. Write an equation with a vertex at 0, 0. I gotta tell you, these are the boring ones. A vertex at 0, 0. I like it when the vertex is somewhere else. Okay, so I'm starting you out on the boring, easy ones. Don't worry, we'll get harder. Okay, so equation, we know that the vertex is at 0, 0. Number 15. So not only is my vertex at 0, 0, I also have a point that passes through negative 3, 3 on my parabola. And I'm told that my parabola opens to the left. Okay, now what was the first tip I gave you? Yeah, sketch what you know. Sketch what you know. All right, so let's just see if we can figure out what we're handed. So I have a vertex at 0, 0. That came from the directions. I know that my parabola is opening up to the left. And I also know that my parabola passes through negative 3, 3. All right, so go back to Sesame Street. If my parabola passes through negative 3, 3, where is this point in comparison to my parabola? It's on the parabola. It's not in like the focus. It's not out of like the directrix. It's on like the vertex. Okay, so negative 3, 3. I'll just say that's right here. Here's negative 3, positive 3. And I also know that it's opening to the left, so my top half is easy, but since my top half is easy and it's all symmetrical, I also have the bottom half that's easy. Too bad that the directions didn't say graph, because if it did, I'd be done. Okay, my directions say I'm supposed to write an equation. What are the 3 things you gotta have to write an equation for a parabola? H, K, and C. Do I have any of those? Good, yeah, I have H and K, so I know that my vertex is at 0, 0. Now I just have to have my C value. I don't have that. Can you think back with me to last week? When I had a circle, and I told you what the center is, and I told you that the circle passes through such and such a point. What did I do with that? What did I plug it in for? Ah, nice. I used the X and the Y temporarily. That helped me out. I already had my H and K. If I have an X and a Y, what's the only unknown that's left over? C, I can solve for C, and then I can write my equation. Okay, so let's go about this the exact same way that I did with circle. So how does this equation start out? Yeah, my y's have to be squared, don't they? Okay, so I've got, help me out here, y. Oh, wait, we don't want to use y though, do we? What do we want to use? 3 minus 0 quantity squared is equal to 4c times the quantity -3 minus 0. Solving is no big deal, okay? So what's on the left side? 9. What's on the right side? After you clean everything up on the right side. Did you say -12c? The 3 times the 4 is your 12, and it's negative. You almost finished. What do? Okay. So you're going to have -912. So you're going to leave it like that. Say no. You better not. What's wrong with it? It's not reduced. Okay, so reduce your fraction. What do you get? -3/4. Okay. All right. What was the directions again? What did it say? Write an equation. Hey, look, I've got everything I need now to write my equation. Okay, so let's start out the equation. How does my equation start out? Y minus 0 quantity squared is equal to 4 times -3/4 times, say it again. Okay, I'm sure that's what I heard the first time. And go ahead and clean it up. Okay, don't leave it like that. It's ugly as it is. So clean it up. So what's it look like after I clean it up? Y squared equals what's that piece in the middle clean up? -3 times x. Okay. All right. New set of directions, number 16. I assume if you have a question, you're going to stop me. Okay. Number 16. New set of directions. Write an equation. You say, that's not a new set of directions. The other one had that same set. Except the other one said that my vertex was at 0, 0. Doesn't say that now. Okay, so now we're getting into the non-boring ones. What does tip number 1 say? Sketch what you got. Okay, so let's draw this. Let's figure out what's going on. Okay, so I have here -1, 2, and I'm going to call this the focus. I'll just put a little F by it so I remember that it's the focus. And then 3, 2, that's my vertex. That's the only thing I know so far. But that picture hands me a lot of information. A lot of information. Okay, what are the 3 things I've got to have to write an equation? H, K, and C. Do I have any of those things? Were any of those things handed to me? H and K, so I'm missing C. Does this picture help me out with C? Yeah, how? Right, it's just the distance between the vertex and the focus. How far apart are they? 4 units? Oh, guess what? My C is 4. Okay, now let's go ahead and start writing our equation. One of my tips says, figure out your concavity and figure out which equation to use. So do I want the x squared equation or do I want the y squared equation? Why do I want the y squared equation? Yeah, how do you know that? Well, remember that the focus is on the inside? The only direction this guy can take is to the left. Now, please, I don't know why I did this when I was writing these notes. I have chosen 3 to do in a row that are all concave left. Don't start thinking that every single parabola in the world is concave left. That's not a true statement, okay? I don't know why I chose 3 in a row that are concave left. Sorry, okay? But nonetheless, I know that it's gonna be concave left, so I know I have to choose the y squared equation. So let's just start writing my equation. Okay, so what's in my first glob? Say that again, y minus, is it y minus 3 or is it y minus 2? Why is it 2? You gotta pick the y piece. Pick the y piece. Is equal to 4 times 4 times the quantity Does anybody have a red flag in your brain? There should be. If I clean this up right now, how will that middle piece clean up? 16. What's wrong with that? Yeah. And what's wrong with that? It's going to the left. My C value should be negative. Let's go back to where I gave you or where you gave me the C. Let's put a negative in there. My C value is negative. Now, you said, Ms. Roberts, why did you do that to us? That was mean. Why didn't you let us catch that from the very beginning? Why didn't you tell us that? Because on your test, there's not going to be a teacher standing over your shoulder going, did you forget something? Okay, you have to remember to look for these things. Okay, so yeah, my C value is negative. So then let's fix that in the equation as well. Okay, when I rewrite my equation, I'm not going to go FOIL out the glob. I'm not going to do all that. All I'm going to do is clean up the middle piece, the 4C piece. All right, so my standard equation will be y minus 2 quantity squared is equal to negative 16 quantity x minus 3. And that will be the cleaned up standard equation. All right. I've been doing a lot of the work here. Let's see if we can get you doing some work. Okay. Number 17, I'm going to give you some guided, whatever. Let me give you a couple hints to start out. Text. Sketch is the word. Sketch what you have. Sketch what you've been given. Try to figure out where the HK is. Try to figure out where the C is, just from your drawing. Could your picture hand you anything? Any good information there? What does y equals 4 look like? The horizontal line. Okay, so here's my directrix and here's my focus. I mean, that's the only two things that you were handed, okay? What does that help you to find? What's one thing that it helps you to find? Well, the vertex? How can I figure out where the vertex is by looking at that? Yeah, isn't it smack dab in the middle of those two? So where's the smack dab in the middle? Yeah, it's gonna be this guy right here, right? It's gonna be my vertex. Smack dab in the middle, so this is gonna be the coordinate 1, 3. What else does it hand me? Oh, my C value. What's my C value? Why is it 1? Oh, wait. It's -1? So is it 1 or is it -1? Oh, okay. Hey, you remember that the focus is always in the inside, right? Sesame Street? Okay. So if the focus is always on the inside, my parabola has to be pointing down. And if my parabola is pointing down, that means my C value has to be negative. Okay. And why is it 1? Okay, so that explains why it's negative. Why is it 1? Yeah, good. It's the distance between the vertex and the focus, or the vertex and the directrix. Okay, so which equation then should I be using? Yeah, the x squared equation. So here we go. X minus 1, quantity squared, equals, go ahead and just clean up the middle piece. -4 times the quantity y minus 3. Okay, so one more time. Actually, it's probably going to be like 7 more times. What's the 3 things I got to have to be able to write an equation? H, K, and C. You know what you got to have to be able to draw? H, K, and C. Same 3 things. Okay, so notice that number 18 says that we're supposed to graph. When I look at this from the very start, what's wrong? What's wrong with it? It's not in standard form. Now, let me just pause here for a minute. This example is actually not even a Math 111 example. It's a Math 110 example. So you could revert back to Math 110. Do you remember that with Math 110, you'd still had an H and a K, but your standard equation was a little different in Math 110. Remember, it was it was called vertex form. Y equals A quantity X minus H squared plus K. Do you remember that? Let me write it. Y equals A times X minus H quantity squared plus K. Remember that from Math 110? So you actually could do this question in a Math 110 way, okay? And I don't care if you do. But since we're in Math 111, I'm gonna do this the Math 111 way, okay? So, but on a test or on your homework, if you did this the way that you learned in Math 110, chapter 3, I'd be totally fine with that, all right? That doesn't bother me at all. They're not all gonna be able to be worked the Math 110 way though, okay? So, so let's work this the Math 111 way. Let's get first a standard form, okay? Now, with standard form, what has to be alone on one side? The squared piece, the whole squared glob. So you see a squared glob up there, right? We just need to isolate it, okay? So we just need to move everything that's not with the squared glob over to the other side. So what's gonna get moved first? That -1 is gonna get moved to the other side. So that's gonna say y plus 1 equals 2/3 quantity x minus 2 squared. And then what gets moved next? The 2/3. And what's the best way to move that 2/3? Multiplied by the reciprocal. So let's multiply by 3/2 on both sides. Because if I multiply by the reciprocal, my 3's and my 2's all cancel. All right, so that's gonna leave me with just my x minus 2 quantity squared. I like that that's alone, okay, because that's what my standard equation in Math 111 does. And then on the other side, it's basically already set up for me, right? So we got 3/2 times the quantity y plus 1. Now, I know those two sides really should be switched, okay, and I'll take care of that in just a minute. But let's figure out, what do we know so far? Where's my vertex? 2, -1. What do I need to do? Not even gonna say that. Not even gonna say that. All right, let's go to the graph. All right, let's put our vertex on the graph. So we've got 2 and -1. By the way, always number your axes. Give me enough to know that I know what you were thinking. Because you could call a block worth 10, but if you don't tell me that, I won't know. Okay. And I've given you a little note here. It says, after graphing the vertex, plug in values to plot a point. Usually an intercept is the easiest thing. And then just use the mirror image to get a good width. Okay. Now tell me, is this guy concave up, down, right, or left? All right, let's do this. Before we answer that question, let's decide two camps. Is it an up or down, or is it a right or left? It's an up down. How do you know it's an up down? Because my x's are squared. Okay. Now take that a step further. Is it up or is it down? Why is it up? Yeah, that 4c is 3/2. And since that's a positive number, I know that my c is positive. Okay, so it's going to be concave up. All right, so I'm not going to draw anything right now other than just two little pieces that reminds me this is going up, okay, because I'm forgetful. All right, now that little note says just plug in another point. Easiest thing is to find an intercept. So here's some good Math 102 and Math 110 reminders. What's true about all x-intercepts? My y value is 0. What's true about all y-intercepts? My x value is 0. Look at your picture. How many x-intercepts are you going to have? 2. How many y-intercepts are you going to have? 1. Which would be easier to find? 2 x's or just 1 y? Totally 1 y. And you said that all y-intercepts have what in common? My x value is 0. Okay. So let's plug in 0 for x. Okay, so my y-intercept will be 3/2 times y plus 1 is equal to, when you plug in a 0 for x, what are you going to have on the right side of your equation? Say it again. I just couldn't hear you. 4. Yeah, your -2 times -2 is going to be a 4. Okay, so let's keep on solving. What should I multiply both sides by? 2/3. Okay, so 4 times 2/3. Can you do that mentally? Just give me a fraction. Don't give me a decimal. What's 4 times 2/3? No. 4 times 2 is over 3, right? 8/3. And then subtract your 1. Okay, what's 8/3 minus 3/3? 5/3. What, Miss Roberts, you expect me to graph 5/3? Where is 5/3? It's not that hard. Where is 5/3? A y value of 5/3. 1 and 2/3. So it's between 1 and 2, a little closer to the 2. So here's 1, here's 2, 1 and 2/3 is right here. Okay, one more thing. Let's go back and look at that note again. After graphing the vertex, done. Plug in values, done. Plot a point, done. And plot its mirror image. Remember, all parabolas are symmetric about the axis of symmetry. So if I graphed the coordinate 0, 1 and 2/3, what else am I going to graph that's the mirror image? 4, 1 and 2/3. Okay, my axis of symmetry is my mirror, and I've got 2 identical pieces on either side. Okay, so now I can draw this, and not only can I draw it, but it's going to be accurate. It's going to have a good width, an accurate width. When you have to graph things on my lab, help me out here. When you graphed circles, were you allowed to just type in coordinates? You were supposed to be. Okay. Now, are you saying no because you couldn't, or are you saying no because you didn't try and you really actually don't know? Because graphing on my lab can be really tricky if you're not allowed to type in coordinates. Okay, all right. Yeah, make sure, can somebody maybe explore that a little when you're working on your parabola homework, and just text me and say, hey, Ms. Roberts, I'm not able, there's no place for me to type in coordinates. I was supposed to give you that ability, but sometimes when things trickle down on a new course, that's one of those things that doesn't always trickle down. Okay, so just let me know. All right, okay. Now, graphing, I got it. Vertex, I've already listed. What's the axis? Because there's 3 things other than graphing that I'm supposed to do. So where's my axis on this? Good. X equals 2. And what's my domain on this? Say it again. Was that you, Juan? Good. And then what's my range, folks? -1 to infinity. And what are you going to put on that -1? Square bracket. Okay, good. Good. All right, number 19, I'm skipping. Looks like number 20, I'm skipping. Surely I'm not skipping all these. No, I am not skipping all these. Why they're not highlighted, I don't know. Let's go to 20. What's the problem? Not in standard form. By the way, this is not one of the ones that I can use a Math 110 method on. I can't go Math 110 on this one. Okay, I never had y-squareds in Math 110. So this is definitely one of the ones that I have to do Math 111 method on. Okay. Man, oh man. Okay, so tell me this. Is this going to be an up-down, or is it going to be a right-left? Right-left. Why is it going to be a right-left? My y's are squared. Think of the standard equation. What would I like to have alone on one side? My y's. My y's. So everything that's not a y, get rid of it. Okay, so first thing, over there on the right-hand side, what should I get rid of first? That -3. Okay, so I'm going to have an x plus 3 is equal to -2y squared plus 2y. All right, what else do I need to get rid of? The -2. The -2. Now, what you might want in front of you right now is the completing the square video. Okay, because we're going to be completing the square. Remember how I told you back on circles, you've got completing the square on circles, and guess what? Parabolas are the same thing, only it's going to be just a slightly harder. And then ellipses are going to be slightly harder than that. And hyperbolas are the hardest of all. Okay, so you might want that completing the square how-to out in front of you. And the completing the square how-to says what's the very first thing on that how-to? What do you got to get rid of? Your a value. Well, my a value is that -2. So you already told me to get rid of the -2, but that's why we need to get rid of the -2. Okay, so how am I going to get rid of the -2? Say it again. How? Undistribute? That's called factoring, right? So it's the backwards version of distributing. So we're going to factor out a -2. Okay, so when we factor out a -2, what's left over? Y squared minus y. Okay. How am I going to get rid of that -2? Still trying to get rid of the -2. What should I do next? Divide both sides by -2. What's another option? And it's an option that we've done a couple times today. Multiply by the reciprocal. That's the easier option, is to multiply by the reciprocal. All right, so when we multiply by the reciprocal, that's going to be a -1/2. Okay, so we're going to have a -1/2 times the quantity x plus 3 is equal to a y squared minus a y. Okay, now we're ready to complete the square. What does completing the square tell me to do? I got rid of my a. That's the first thing it tells me. What's the next thing that it tells me? What was the first piece that you said? Okay, so take half of b. Take half of b. What is half of my b? -1/2. And do what to that? So what's a -1/2 times a -1/2? +1/4? Okay. What am I supposed to do with that +1/4? I'm supposed to add it to both sides. I didn't leave myself a whole lot of room here, but I'm going to add a 1/4, and I'm going to add a 1/4. There it is. Squeeze it in there. So I'm adding a 1/4 to both sides. What's the next step on completing the square? I heard it. Say it again. Factor the trinomial. Yep, so here's my trinomial. I don't want to factor that guy. So what is that guy going to be? Remember the shortcut? Y minus 1/2 quantity squared. Now remind yourself of our goal here. Our goal was to get the standard equation so that we can graph and do all that other junk, okay? So if my goal is to get the standard equation, do you see that the standard equation is starting to emerge? See that? The right side is good. Don't mess with it any further. I mean, once you got it where you like it, don't mess it up, right? So this side is good. The left side, not so much, because I have that +1/4 in there, and that's not part of my standard equation. So now I have to clean up the left side so that I can make it look like, remember what it's supposed to look like? 4 times c times x minus h. That's what it needs to look like. All right. So what am I going to do to start cleaning that up? Oh, you guys are so quiet. Miranda, what do you think you're going to do there? Oh, not an option. Okay. What are you distributing? I'm all right with that. Thanks, Aaliyah. All right, so let's distribute the negative half. Miranda, you over. So you got a negative 1/2 x. When I keep distributing, what's the next piece of my distributing going to look like? Negative 3/2. Let's go ahead and just add in our 1/4 that was already sitting there. So this is kind of that, did your mom ever tell you in order to clean up your room, you have to mess it up first? You know, like all that stuff you threw under the bed and threw in the closet, she's going to pull it all out and make a mess so that you can clean up properly. Okay. So I'm messing it up so that I can clean it up. So what's next? Not yet. Not yet. But that's going to be down the line. What do I need to do before I factor out that 1/2? Yeah, I need to combine my like terms. The 3/2 and the 1/4, they're like terms. Okay. So my brain is saying, go ahead and get a common denominator. 3/2 is the same thing, my brain says, as 6/4. Okay. So I have a negative 6/4 and a positive 1/4. So what does that give me? Negative, say it again, negative 6/4 plus 1/4. Okay, with your masks on, I cannot tell what in the world you're saying. So I'm just gonna assume you told me negative 5/4. Yeah, okay. And then I still have the negative 1/2 x in front of that. I'm not even messing with the right side, so I'm being a little lazy right now. I'm not writing it down. Okay. What was it? Okay, it's got to look like this. It's getting closer. See how that x is standing alone? Okay, that's the problem now. How am I going to get x to stand alone? Now's where I want to factor. And what do I want to factor out? That negative 1/2. Okay, so I have a negative 1/2. When I pull it out of the negative 1/2 x, it just leaves me with an x. Okay, when I pull a negative out of a negative, what happens? Positive. And I love this with fractions because it's actually fairly easy. Pull a 1 out of the 5, what's left over? A 5. And I don't mean by adding or subtracting. Remember, you're dividing. Okay, you're dividing. Factoring is division. And then take a 2 out of the 4, and what's left? 2. What's a good way to check your work? Just to make sure, because sometimes this gets a little, I don't remember if that's right. What's a good way to check your work? What's that? What'd you say, Leah? Yeah, distribute. Redistribute it. If you redistribute, you should get the line above. What is a 1/2 times 5/2? Multiply the tops, what do you get? Yeah, what do you multiply the bottoms? What do you get? 4, 5/4. Oh, look, they matched. Ooh, I did it right. So if you redistribute, you can always check your work that way. Okay. All right. So finally, that side looks the way I want it. Okay. Let's see. The directions said graph. Give the vertex. Give the axis. Give the domain and range. Okay. So I'm actually ready to begin this question now. That's a lot of work just to begin. Right? I know. Crazy, huh? What's my vertex? -5 halves. What's the other piece? 1/2. Okay, so there's the vertex. Let's go put it on the graph. Where is -5 halves? Tell you what, when you're graphing, probably the easiest thing to do is to go by blocks of 2. Go by blocks of 2. So I'm gonna have 1, every unit, I'm gonna assign it 2 blocks. So tell me then, how many blocks do I have to go to get to -5 halves? Okay, so 2.5, so how many blocks is that? 5 blocks. Here's -1, here's -2. So then here's -5 halves in between 2 and 3. And then how far up do I have to go? How many blocks? 1 block. Okay, so there's my vertex. Up, down, right, or left. By the way, we already figured this out. It's just been so long ago that we forgot. Left and right. So is it going to be left or is it going to be right? To the left. Do you remember that little note I left you? It said once you get your vertex, what's the next thing that you should go do when you're graphing? Go back and look at it. That's fine. I only gave it to you today. What's that note say? Yeah, plug in values to find an intercept. All right, look at your picture. How many y-intercepts are you going to have? Yeah, none. So maybe you shouldn't try to go find a y-intercept. How many x-intercepts are you going to have? 1. Let's go find that. All x-intercepts have what in common? A y value of 0. So let's go to our standard equation. And by the way, here's a trick. You can go to any equation you've worked with so far. You can either go to the standard equation, which was down here. Here's my standard equation. Plug in 0 for y. Or you can go to the original equation. They're the same picture. It's just 2 different equations that are showing the same thing. So you tell me, what's easier to plug in a y value of 0? The standard or the original? So the original, because if you plug in a 0 for y on the original, what do you get? X value of -3. That's pretty easy. An x value of -3. Okay, so I'm going to have then my x-intercept will be an x value of -3 and a y value we plugged in 0. Let's go back to our graph. That makes it easier. Here's my -3. Hey, that note that I gave you said, get the vertex, then go plug in a point to get an intercept. And what was the next piece of that note? Yeah, use a mirror image. So there's one more point I need. Where should I put it? Yeah, -3, 1. -3, 1. And then that's going to give me a good width for my parabola. Okay, so I got my graph. I've got my vertex. Where's my axis of symmetry? Y equals 1/2. Good. Where's my domain? -infinity to, say it again? Yeah, -5 halves. It's that X piece of my vertex. What's my range? Negative infinity, positive infinity. Okay. Now, one of the reasons that I like to work this question in class is because you have to deal with so many fractions. Okay. I know that the majority of students do not love fractions. I know that. Okay. But I'm totally fine with them. So I have no problems with using them. All right. So we'll keep on using. Okay. So there was a couple then that I left that I didn't do. So example number 19 is one of them. Example 14 is one, and example 12 is one. So I'm gonna let you start working on those. Start at the bottom and work your way to the easy. Start at the hard one and work your way up. And I'm gonna walk around and just kind of help you out as we go along. And you're welcome to work together. You don't have to, you can work alone, but you're welcome to work together. If you do, you probably need a mask on.